Question number 1. For what values of k will the graphs of the following equations intersect in quadrant 3? Hint: this is the range of values that can be written as an inequality. Line L is y equals k x plus 14, and line M is y equals x plus 28. Okay, so first we know that line M's slope is 1, as we can see here. And since these two lines have to intersect at quadrant 3, you know that k cannot be 1, because if it is 1, these two equations have the same slope, therefore they will be parallel, so they won't ever intersect. So 1 cannot be the answer. And you also know that k cannot be a negative, because if line L's slope is a negative, then as you can see, and its y-intercept is 14, say this is 14, and the slope is negative, then it goes down like this, and you have line M, which is a positive, and it starts at 28, the y-intercept is 28, and it goes positive, then it's going to intersect always at quadrant 1. Therefore, k cannot be a negative. So what you have to do is now you know that k must be less than 1. Less than 1. However, it can't be a negative either, since the minimum you can go, I would say, would be 0, and the maximum you can go would be 1. I just find whatever number is in the middle, which is 1/2. So I find 1/2, and so I tested it out. Maybe 1/2 can be k, or 1/2 can be the minimum. So let's try more than 1/2 and less than 1/2 and see which one works. So if we make k more than 1/2, which is 3, let's say one number, 3/4, and 3/4 because it is between the minimum number of 1/2 and below the maximum number of 1, so it's 3/4. So let's say this is 3/4, therefore the slope is 3/4 and the y-intercept is 14, and one box is equal to 2 units, so 2, 4, 6, 8, 10, 12, 14. 14 is right here, and the slope is 3/4, so 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, and we graph this out. Right. Next, we graph this line M, which is y equals x plus 28. And so this y-intercept is 28, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. And the slope is 1. So, slope is like this. Now, you can obviously see that the lines are spreading out as you go towards the first quadrant. Therefore, you know that these two lines had intersected in quadrant 3. So now, you know that in quadrant 3, if you have a number, if k is equal to a number more than 1/2, it would intersect in quadrant 3. Now we're going to try it out for a number which is less than 1/2 and see if that intersects at quadrant 3. And if it doesn't intersect at quadrant 3, therefore we know that 1/2 would be the minimum that k could be, and 1 is the maximum that k could be. Therefore, the range of k is between 1/2 and 1. Okay. So right now, all we know is that the maximum k could be is 1. And we tried out a number that was bigger than 1/2, and k which we tried was 3/4, and 3/4, if k is 3/4, the two lines do intersect at quadrant 3. Next, we're going to try a number that's less than 3/4, let's say less than 1/2, which is 1/4. So let's make k 1/4. So line L is now y equals 1/4 x plus 14, 2, 4, 6, 8, 10, 12, 14. So the y-intercept is 14, and the slope is 1, 1, 2, 3, 4. The slope is 1/4. Right. Let me graph this. Approximately. And we graph line M as well, which is y equals x plus 28. And 28 is up here, which is the y-intercept, and the slope is still 1. Right? And then we graph this line as well. Since these two lines intersect in quadrant 2, we know that k cannot be a number less than 1/2, but k can be a number more than 1/2. Therefore, the inequality would be k is more than 1/2 and k is less than 1. Now, we need to check this. So let's just put in some random number. Just substitute any number between 1/2 and 1 into k. So let's just say 6/8. Okay. So let's pretend that k is 6/8, and we can check it. And if this does intersect in quadrant 3, then we know that this inequality is correct. And you can also substitute any other number for k between 1/2 and 1, but I'm just going to randomly choose 6/8. So 6/8, let's say that now line L equals y equals 6/8 x plus 14, and line M equals y equals x plus 28. So we graph line L. The y-intercept is 14 still, and the slope is 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4, 5, 6, 7, 8. Right? And just so you know, 6/8 is equivalent to 3/4, so we can try any other number like 7/8, for example. Let's try 7/8 then. Then 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 8. 1, 2, 8, right? And then we graph this out. And this line represents the equation, line L, y equals 7/8 x plus 14. Now we're going to graph line M, which is y equals x plus 28. 28 is right here, and we have right? And we see that since these two lines are spreading out as you go towards quadrant 1, we know that these two lines would have intersected at quadrant 3. Therefore, this inequality is correct. And the check is over.